So hello again. Now we will be talking about coordinate systems. We will cover orthogonal coordinate systems in this topic, and this is just because it'll simplify our math and make our problems and our solutions easier. What orthogonal coordinate systems means is that all three unit vectors will be perpendicular to each other. So let's start with the Cartesian coordinate system. This is the system that we are most used to. It is the regular XYZ system and is characterized by the unit vectors XYZ. Unit vectors are written with a little kind of hat on top. So basically any vector within the Cartesian coordinate system can be described with an X, Y, and Z component, even though these components might be functions. That's totally fine. And a vector is written in vector form with the X component, the Y component, and the Z component. There is not much else to explain about Cartesian coordinate systems, since we've been covering this for, a very long time, and you should be familiar with this one. Now let's cover the cylindrical coordinate system. It is probably one of the most useful coordinate systems, and just like the name says, it is based on a cylinder kind of shape. So here I've drawn my cylinder, and now let's try to visualize what it means to find a point in the cylindrical coordinate system. So the cylindrical coordinate system has the following unit vectors. It has lowercase r, theta, and z. Let's remember the hats for the unit vectors. And now let's look at what this means. What is lowercase r? Well, lowercase r is going to be the radius. So basically, at what point of a radius we are looking at. So it could be up to the actual cylinder, it could be a little less, it could be more. The cylinder is just for reference. So basically the radial distance from the origin. Then we have theta. Theta is going to have a reference point, which is going to be, say, this line right here, which we will consider as the origin. And theta will represent the angle between the radius that we were talking about and the origin. So as you can see, that theta is going to be less than this theta. And that way we're able to see where on the 2D circle we are going to find our point. Now our last unit vector is z. Z is very easy. It's going to be the exact same value as in the Cartesian coordinate system. So it is just going to be how high up the point is. Let me write down that this distance is going to be r, this one's theta, and finally, say we have a point at this height, that will be the z component. So a vector in vector form for the cylindrical coordinate system will just be r hat, theta hat, and z hat. And again, these can also be functions, so be careful with that. We will also look into how it'll affect all the calculations that we've been doing and that we will do. So now let's talk about spherical coordinates. Just like cylindrical was based on a cylinder shape, spherical is going to be based on a sphere. So here I've drawn my sphere, and I'm going to put my origin in the center of the sphere. Now the unit vectors for spherical coordinates are the following. We have capital R, theta, and phi. And these can be written in vector form with the components r hat, theta hat, and phi hat. And again, also these can be functions as well. Now let's look into what these mean. So the capital R hat is going to be very similar to what the lowercase r hat in the cylindrical coordinate system represented. However, it is going to be different in the sense that it is no longer going to be limited to the 2D plane. So it's no longer a radius that can just do this. It is a radius that can go outward and upward, like so, and basically any direction within the sphere. Now let's look at what theta and phi mean. Both of these are going to be the angle values of the point. And basically what this is going to be is that theta is going to represent the same theta that we covered in the cylindrical coordinate system. So basically we're going to have a reference line over here on this circle that is kind of, in the middle of the sphere, and then theta is going to be the angle between that point and the component. So let's look at this with one r that is not on this circle. So say this r is going to have a component here. So if we were doing cylindrical and this were our circle, then this would be our r over here. But we are doing spherical, so our capital case R is going to go upwards. So it'll have a different component. So our theta would now be the angle. Let me clean up so that we can see this better. Okay, so now that I've cleaned up, we see that the component and the reference are going to be an angle theta apart. And that is going to be our theta component of the vector. And finally, the phi is going to represent the angle according to the other circle I've drawn here. So we are going to put in a reference right here, for example. So it goes until that circle, because, well, this is not perfectly drawn, but that's going to be our reference. So we see that the kind of vertical component in the radius or vector that we are looking at, it is going to be a certain angle away from our reference on that circle. And that angle right here is going to be called phi and will be in the direction of phi hat. And over here is capital R hat. Remember to use capital R for spherical, since it is a convention, but it is very useful for remembering and differentiating between the two. So that is all on the orthogonal coordinate systems. It will definitely make our problems easier to solve, and they are extremely useful. So thank you for watching.